Work done on an object by the net force is equal to the change in the object's kinetic energy. That is what we call the work energy theorem, and it is given by this formula, where work net is equal to delta K being the change in the object's kinetic energy. Now, energy is a scalar which has an SI unit measured in the joule. Now, because it's a scalar, it means it does not typically need direction. It only needs magnitude. That's what scalar means. Okay, looking at the question that you see on the screen, these are the type of questions that you are going to be asked when you need to calculate work done by a non-consecutive force. Now, remember, these forces like friction, air friction, air resistance, these forces typically do not act like applied forces or potential forces or F parallel as we know from our questions in Newton's law, right? But a non-consecutive force is defined as a force of which work done in moving an object between 2 points depends on the path taken, right? So these forces only act if the object is moving from one point to another point. This is when now the forces are at work, okay? Now, if we go here, we can quickly do this. We can quickly say this. We can say that W net will equal to change in potential energy plus change in kinetic energy. Remember, the box is at a height. So because now we have that height factor, which is why we have potential energy. And W net basically would be the work done by obviously all of the forces combined, but what would be left over would be those non-consecutive forces. Okay, so I just want to make sure that you can see this. Go back here. Okay, so the box mass is 100 kgs. Slide down the slope. Its velocity increases from 0 to 4 meters per second. Point B. The diagram, calculate work done by the non-consecutive force. Okay, pretty simple. Let's go here. Now, we are going to say that change in is mass, gravity, height final minus mass, gravity, height initial plus a half mv squared final minus a half mv squared initial. Okay, the final one is 0 height. First one is 100, 9,8 multiplied by 1, right? Plus I have 100 multiplied by 4 squared minus 0. Right? Okay. Then what we have here, we have 100 multiplied by 9,8, which is negative 980. We add that to a half multiplied by 100 multiplied by 4 squared. We add that to 800. We now have a difference of negative 180 joules. Remember, energy is a scalar quantity, right? Just calculated all of the energy here. This means that the work done by the non-consecutive force is 180 joules. And you can see we got a negative answer, which is more proof of energy being lost due to the non-consecutive forces. Okay, we're going to do another example just to help cement the knowledge that we received in this video. State the principle of conservation of mechanical energy. Now, you need to sing about these. Okay? You really need to sing these definitions because this is a way for you to collect marks, potentially getting 100% for some sections. This could be a make or break in whether you pass the grade or not. Okay, the principle of mechanical energy states that energy cannot be created or destroyed, but can only be transformed from one form to the other. Learning this thing and being able to say it in your own words is more important than actually knowing what the dictionary version is. Okay, is mechanical energy conserved? Now, I've always had an issue with this because sometimes you know the answer, but you don't know what they're asking you. Okay, the word conserved means protected from harm or loss or kept in its original state. Okay, so basically what the question is asking is that, is mechanical energy protected from loss? Which is no, right? If an object starts from a height or it starts from ground zero and moves to a height, the potential energy will increase while maybe its kinetic energy decreases. So it is not conserved. Okay? That's simple. That's what conserved means. It means is if the system is protected. Okay? Are we happy? Okay. Now we go to the third question. Let's say, assume that the average frictional force between the track and the track is constant along P and Q. Calculate the average frictional force experienced by the track. Okay. So now, this is what you're going to do. In order for you to calculate the frictional force, you would need work done by the non-consecutive forces, which is the change in kinetic plus change in potential energy. Okay? Now we need a lot of room here. So I'm going to say that mgh final minus mgh initial plus a half mv squared final minus a half mv squared initial, all in brackets. Okay, then now I go and I fetch my information. What do we have? We have 1.4 kgs, 1.4 kgs has a speed of 0.6. That's our initial speed, and it's going down. And we have our initial height of 1.5 meters. Okay, curve section, and the slope is 1.8 meters long. Okay, when the truck reaches point Q, it has a final speed of 3. Okay, let's go. Gonna put these in our equation over here. Now we're going to say that 1.4 9,8 final is 3 minus 1.4 9,8 initial is 0.6 plus I have 1.4, sorry, no, our velocities or velocities are supposed to come here. So final velocity is 3 squared minus a half times 1.4 times the initial velocity of 0.6 squared. Okay, here what we need to do here is we need the height. Obviously we're going for a height of 0, and then that initial height. What is that initial height? The initial height was 1.5, so we put 1.5. Okay, now we're going to put this in the calculator. So we're going to say that the work done by the non-consecutive force is equals to 1.4 9,8 times 1.5 is equals to negative 20.58 plus a half 3 squared minus a half 1.4 0.6 squared, which is 6.05. Sorry about that, lost connection there. Okay, close bracket. First, what we want to do, we're going to find the work done by this non-consecutive force, which is negative 14.51 joules. Now, we know that work is equals to force times distance times cos of the angle. Okay, so we know that negative 14.51 is equals to force times, what was the distance traveled? The truck traveled a distance from P to Q of 1.8 meters. Okay, 1.8 meters. So traveled 1.8, and because it's a frictional force, it was acting directly opposite the direction which the truck was traveling, which makes the angle 180. Happy? So now that makes 1.8 multiplied by cos 180 to be negative 1.8. Okay, so it's negative force 1.8, which is equal to negative 14.51, which the force then will equal 14.51 divided by 1.8, which is 8.06 newtons of frictional force. I'm happy about that.